Well, here's a complex looking monstrosity of an equation. Is there anything we can do to solve for this 2 cosine squared 3x plus 2 cosine 3x minus square root of 3 cosine 3x minus 3 radical 3 equals 0 on the interval from 0 to 2 pi? And I've been saying x, I mean theta. How could we do it? Well, the one thing we might notice is that there are 4 terms right here. If we're to make a substitution in which we said u was equal to the cosine of 3 theta, then our equation would look more like this: 2u squared minus 2u minus radical 3 times u minus radical 3. And we note with 4 terms like that, there are like factors in the pairs here and here. So we factor out 2u from this first one, and we're going to get something that looks like u minus 1. And sure enough, if we factor out square root of 3, I'm sorry, this is a plus right here, better be careful. We factor out negative square root of 3 from this second pair of terms, and we're going to get u plus 1 as well. And so our factorization right here comes out to be 2u minus the square root of 3 times u plus 1. Now, we should go back and, of course, make the substitution back into our original equation here. But this time, let's use the factored form. We have 2 cosine of 3 theta minus radical 3 in one factor, and we've got cosine of 3 theta plus 1 in the other factor, set equal to 0. So, of course, this means we need to set each equation, each factor, equal to 0 individually. Let's take on 2 cosine of 3 theta minus radical 3 equals 0 on the left here, and we'll take on cosine of 3 theta plus 1 equals 0 on the right. Now, because we have a multiple angle right here, right, be very aware that this means that what's going to happen is we're going to get the kind of solution in which we can get more than one answer or 2 answers on the interval from 0 to 2 pi. And so what we need to do is we need to go through that general answer, like as if we were said over all real numbers. What would this look like? So what that means to me is this. I'm going to take cosine of 3 theta and isolate it on the left. I've got cosine of 3 times theta is equal to square root of 3 over 2. And I know that this means that the kind of angles for which this would be true would be the angles in which 3 theta would be equal to, let's see, cosine radical 3 over 2 is associated with pi over 6. And of course, anything coterminal with pi over 6, which is in the first quadrant, and then also in the fourth quadrant. In the fourth quadrant, that's 11 pi over 6 plus 2 pi n. Now, we could also say negative pi over 6, because that would also be in the fourth quadrant. But in this case, I'm keeping my basic answers between 0 and 2 pi. And in order to isolate theta itself, I have to multiply everything by 1/3. So that means I actually have pi over 18 plus 2 pi over 3n. And I will have 11 pi over 18 plus 2 pi over 3 times n. Well, these are general solutions. We haven't gotten the solutions on the interval from 0 to 2 pi yet, right? So what we need to do is that means we're going to have to start substituting in values for n. So the way we do it is we take each of our answers right here, and we just start letting n equal 0, n equal 1, and n equal to 2. We're going to stop there, though, right, because we don't want n equals 3. If n equals 3, that means we're taking 3 times 2 pi over 3, and that's greater than 2 pi, and we don't want that. So if we substitute in n equals 0, we can make a little table right here. We would see that pi over 18 is the kind of solution we'll get if we let n equal 0 in this first equation, and 11 pi over 18 is what we'll get if we let n equal 0 here. Let n equal 1, what's going to happen? Well, I'm going to keep in mind here, 2 pi over 3 is being added to something over 18, which means I'm going to have to multiply by 6 to get that common denominator. And so this is the same thing as 12 pi over 18. And so remember, we're adding multiples of 12 pi over 18 to whatever number we've got right here. Well, 12 pi over 18, that's 2 pi over 3 times 1 plus pi over 18. That's going to be 13 pi over 18. And letting n equal 1 right here, 12 pi over 18 plus 11 pi over 18 is going to be 23 pi over 18. Still less than 2 pi, right? Because 2 pi is going to be equal to 36 pi over 18, right? So we're still less than that. What happens at n equals 2? Well, that means that we're going to take this, and this is going to be like adding 24 pi over 18. That's a 24 up there. Probably not a very good one, but you'll get the idea, I hope. 24 pi over 18. We're just taking this guy up here and multiplying it by 2. So we're going to take pi over 18 plus 2 times 2 pi over 3, that's 24 pi over 18. So pi over 18 plus 24 pi over 18, that's 25 pi over 18. And I'm going to take 23 pi, or 11 pi over 18, add 24. That gives me 35 pi over 18. Look what I've got here. I've got 1, 2, 3, 4, 5, 6 answers. And we're not done yet, because we also know that cosine of 3 theta plus 1 equals 0 is another piece of this solution. So let's isolate it. Cosine of 3 theta would be equal to -1 when we have the kind of angles where 3 theta is equal to pi. Right? That's it. On the unit circle, -1 is only achieved at pi, plus any angle coterminal to that. So what I'm going to do now is I'm going to divide everything by 3. So I get theta is equal to pi over 3 plus 2 pi over 3n. If it helps you to think about it, cosine of 3 theta is the kind of function that would have a period of 2 pi over 3, right? We take 2 pi over b, remember that? So let's find out what happens when we let n equal 0. Of course, that gives us pi over 3 as a solution. If we let n equal 1, that's going to give us pi over 3 plus 2 pi over 3 times 1. That's 3 pi over 3, or pi, as a solution. And if we let n equals 2, we're going to have pi over 3 plus 2 times 2 pi over 3. That's 4 pi over 3. That gives us 5 pi over 3. And that's another solution. So in total, 1, 2, 3, 4, 5, 6, 7, 8, 9 solutions to this equation. This is why we need to go through this multiple angle model in order to find our solutions. All right, good luck.